Welcome back to Sleepy Cosmos, your quiet corner of the universe where we take gentle breaths and even gentler journeys through the stars. Tonight, we're setting off on a calm and slow exploration of the idea of whether the universe has an edge. You float here weightless with no passport and no customs to worry about, just curiosity. And don't worry, no black holes are hungry enough to nibble at you tonight. They're all taking a nap far, far away. It might sound straightforward, or maybe a bit odd, but as you sink deeper into it, you'll find it unfolding into something vast and quietly mesmerizing, much like the cosmos itself. As usual, my hope is that this video helps you relax into sleep, or at least lets you step back and see your worries from millions of light years away. Of course, there's always a chance it's fascinating enough to keep you awake. If that happens, well, at least you'll drift off with a sprinkle of cosmic wonder in your thoughts. Before we gently launch into this starry voyage, it would mean a lot if you'd hit like and subscribe, but only if you truly enjoy what I create here. Also, I'd love to hear where in the world you're tuning in from and what time it is there. Are you curled up in bed in Paris at 11 p.m., or maybe relaxing on a sofa in Sydney while the sun shines brightly outside? Drop a note in the comments. It's always wonderful to see this sleepy little constellation of viewers spread across the globe. Now dim the lights, imagine the stars above your bed. Settle in. You don't have to keep track of every word or stay alert. Just let the gentle flow of these words surround you like a soft cosmic glow. And as we embark on this slow, peaceful journey through the vastness of space, remember this video is here to help you unwind and learn, not to replace any medical advice. Ready? Let's float into tonight's cosmic journey together. You drift on, weightless and unhurried, through this expanse of shimmering black velvet, and with every inch you travel, the darkness grows denser, more enveloping, and yet somehow full of light. The little dots of brightness that first caught your eye begin to morph, becoming gentle pinpricks of twinkling, and then, slowly, galaxies. Vast swirls of stardust and suns, spiraling quietly around unseen centers. You sense the immense scale of it all, that each twirl contains billions of stars, each star possibly hosting its own planets and each planet its own stories. Still, there's no edge in sight. No wall, no barrier, no cosmic fence. It's like floating inside an endless ocean of stars, where trying to find a border is like trying to find the edge of the sky. That question burrows into your mind again. Is there a limit to this space? And if so, what would that even feel like? A sudden transition? Curtain? A crash? You move toward a particularly bright spiral galaxy, swirling in shades of pale blue and soft amber. You imagine these are the colors of countless suns, each with its own solar family. Gradually, you float closer until you find yourself skimming the outer halo of that galaxy. Here, stars are sparse, drifting in elliptical orbits, ghostly lights moving in slow circles. You drift alongside one, and as you look closer, you see a planet orbiting it, a pale blue dot. From this distance, the planet seems calm, serene, but you remember that more than likely, it's seething with storms, tectonic shifts, maybe even life. It dawns on you, even within what seemed empty, there is structure. The universe isn't chaotic emptiness, it's more like a tapestry woven with threads you can't count. And you realize, the question of an edge isn't just about reaching a blank wall. It's about what lies beyond what we can see, what we can measure, what light has reached us. You remember a standard cosmology fact. The observable universe is finite in size, about 93 billion light years across. That's what you could call your local bubble of what you can see. Beyond that, there's light that hasn't had time to reach you yet. So the more precise question becomes, does the universe end beyond your horizon, or extend forever? Scientists debate it. Some say it's infinite, others contend it could be finite and curved. As you drift out past that spiral galaxy, you pass through a faint sea of intergalactic gas and dark matter. Invisible but for its gravitational pull. And here's your offbeat trivia. Dark matter makes up about 27% of the universe's mass energy. It doesn't interact with light, so you can't see it, but it's like the scaffolding on which galaxies hang their stars. Without it, galaxies wouldn't spin the way they do, they'd fling themselves apart. Swallowed in that realization, you notice that in some galaxies, stars are disappearing into black holes, sinking into invisible depths. And you can't help but smirk a bit. Scientists still don't know what lies inside a black hole. They argue quantum gravity equations humming in some chalk-scrawled lab somewhere, but so far it's guesswork. Black hole interiors remain one of the big mysteries. What a perfect cosmic spoiler for the night. You keep floating, now through a denser region filled with more galaxies than you could ever possibly count. Stars cluster and form filaments, like cosmic threads. It feels almost organic, like a neural network or veins in a leaf. You drift past a cluster where galaxies collide, gentle mergers that take millions of years. Not explosive fireworks like sci-fi would have you believe, but slow dances of gravity, each galaxy pulling and stretching the other. You pause near one such merger. You see long tidal tails of stars, dust stretching between colliding systems, and you think about how galaxies build larger systems through these encounters. Scientists call this hierarchical structure formation. It's a mainstay of cosmology. Small objects merge to form larger ones over time. But you also recall a whimsical tidbit. The cosmic microwave background radiation, that faint afterglow of the Big Bang, is actually fossil light from when the universe was only about 380,000 years old. Tiny temperature fluctuations in that background seed all galaxies billions of years later. Think of it as the infant giggle of the cosmos. Your mind drifts again across the miles of nothing turned everything. You imagine traveling faster and faster until your speed reaches light speed. But still, there'd be galaxies ahead you couldn't see yet, the ones whose light hasn't reached you. It's a humbling thought. You might pass a star at full light speed, but if its light hasn't traveled to your current time frame yet, it remains invisible to you. The universe extends beyond your gaze, and scientists still argue. Is that extension finite or infinite? Some cosmologists think space is flat on large scales, implying potentially infinite extent. Others allow for slight curvature, meaning it might wrap around eventually, like the surface of a sphere in higher dimensions. You press forward farther. In this higher density map of the cosmos, you cross into a glowing filament, a corridor of galaxies stretching across hundreds of millions of light years. It's as though you're inside a grand cosmic highway. The stars there hum with activity, star formation, supernovae, swirling gas clouds. You imagine nebulae blazing purple and crimson, enormous nurseries birthing new stars. You drift into one such nebula, kaleidoscopic gases swirling, illuminated by young hot stars. You feel almost childlike in awe. This entire region might be hundreds of light years across, yet you pass through it in mere moments. You think, in such nebulae, dust and hydrogen gas clump under gravity to make new stars. That's basic astrophysics, but still miraculous, isn't it? At the same time, there's an offbeat factoid. Some volcano-like exoplanets might spew lava oceans, or one exoplanet is made of carbon so rich that its crust could be graphite or diamond. Again, diamond weather? A planet where instead of rain, chunks of diamond hail down. Between the filaments, there are immense voids, regions tens of millions of light years across with almost nothing in them. To pass through one feels silent, like sliding into a surreal dreamscape where time stretches differently. In those voids, even astronomers are puzzled. Why are they so empty? Theories abound. All the while, your journey never reveals a wall or end. Instead, it reveals more complexity, more depth. The dark energy that fills space presses outward, accelerating expansion. Dark energy makes up about 68% of the cosmos and is driving the accelerating expansion. That one fact still cracks scientists' brains. They argue over what dark energy even is: cosmological constant? A new field? Something more exotic? You drift on and on, thousands upon thousands of light years, past galaxies, voids, clusters, nebulae. Your senses are calm, your breathing slow as the narrative flows through cosmic landmarks. Finally, as you cross beyond the densest region you've so far seen, you drift into a deep, soft glow, a swath of nebulous luminescence. It's unlike anything you expected. Not an abrupt wall, but a gentle haze of light diffused across a large zone. You reach out and gently brush it. It parts like silk. Through it, the view changes. The stars beyond appear softer, deeper in color. Deeper space. You realize with a quiet delight, this isn't an ending at all. Not a barrier. Not a crash. It's more like stepping through a threshold into a quieter, deeper realm. Maybe that's what the edge would feel like if there ever was one. Not a wall, but a transition into something subtly different. For now, though, nothing stops you. No edges. Only the soft glow leading ever onward. You sink into that realization as if inhaling cosmic air. The universe may stretch on infinitely or loop around like a curved surface. For now, you don't have to choose. You just float, drifting deeper, trusting that whether finite or infinite, this journey continues. You've just drifted past that soft haze, and as you glide further, something peculiar begins to happen. The stars, those tiny gleaming freckles on the universe's face, seem to be slowly sliding away from each other. At first you think it's just your imagination, like the way objects on a train platform appear to move when the train starts. But no, this isn't you moving past them. This is everything moving apart. It's like someone has gently taken hold of space itself and is stretching it, pulling it open like warm dough. Galaxies that were once comfortably close are now drifting farther apart, like raisins being tugged in a rising loaf. And the really strange part? The dough doesn't just stretch at the edges, it stretches everywhere all at once. That means no matter where you are, the dough is expanding around you. There is no special center. As you float and watch, you can almost feel it in your own body. Your arms don't grow longer, thankfully, and you won't wake up with cosmic noodle limbs. But the space between galaxies swells in every direction. If you try to mark two galaxies with pins, that pincushion just gets bigger. This is one of those big cosmic facts. Space itself is expanding and has been since the Big Bang. It's not that galaxies are racing through space away from one another like cars speeding off in opposite directions. It's more that the very fabric between them is growing. Even if the galaxies are just floating there minding their own business, the balloon skin they rest on is being blown up. You picture this inflation like yeast working on a cosmic lump of dough. You can almost hear the faint hiss of rising air, except here the yeast is physics, and it's been working non-stop for nearly 14 billion years. As you watch, a galaxy that was once nearby grows tinier, slipping away like a retreating ship. The light from its stars takes longer to reach you, stretched thinner and redder as space stretches. Astronomers call this redshift. It's like the universe has taken a rainbow and pulled it until the colors are tired and low-pitched. It's strange, isn't it? You came looking for the edge of the universe, but the more you drift, the more everything around you pulls away, so fast that, in a sense, the edge is running away from you. You think back to Earth for a moment. Back home, expansion is easy to ignore. The room you sit in doesn't swell like a balloon, and your cup of tea doesn't suddenly fly across the table. That's because gravity and other forces are strong enough locally to glue everything together. The dough stretches only on the biggest scales, between galaxies, where there's nothing to hold them tight. In this slow-motion ballet of stretching, you spot something delightful. Over on your left, a galaxy cluster clings together stubbornly, refusing to drift apart. It's a stubborn bunch of raisins sticking to one gooey patch of dough. Even though the dough tries to pull them apart, their mutual gravity keeps them cozy. It's kind of heartwarming, cosmic family values in action. And then, of course, there's the truly mind-bending bit that scientists like to remind us of: this expansion is accelerating. It's not just that the dough is rising, it's that someone turned up the oven. The raisins are being pulled apart faster and faster as time passes. The culprit behind this strange behavior? Dark energy, an invisible pressure that pushes space to stretch at an ever-growing rate. You let yourself drift sideways through the dough, almost like you're sliding between the swelling bubbles of a giant bread loaf. You can't help imagining the smell of bread. It makes you wish you had packed a snack before launching yourself into the void. And you can't help laughing softly to yourself. Here you are millions of light years from home, and all you can think of is a bakery. To distract yourself from your growling stomach, you focus on the view. The pattern of galaxies now looks like a great cosmic sponge. Bright points of light form filaments, and between them are vast, airy voids. It's as if someone took a bite out of the bread and left behind tunnels where no stars shine. Inside these filaments, you start noticing other oddities. You pass a galaxy that has a strangely warped shape, like someone pressed a thumb into one side of the spiral. Astronomers think such warping comes from galactic collisions and gravitational tugs. You think, so even in an expanding universe, galaxies can still bump into each other. It's like raisins clumping together as the bread swells. They might be carried apart overall, but locally they still tangle. Another odd fact pops into your head. There are galaxies so far away that their light, stretched by the expansion, has become invisible to the human eye. It slipped into infrared, hidden from view. If you could see all wavelengths, the universe would be even more crowded with light than it already appears. That thought alone makes you feel both awed and slightly cheated, like you've been staring at a great mural all your life, but with half the paint hidden under a fog. As you keep drifting, you remember something scientists love to debate. Will this expansion go on forever? Some models say yes. Galaxies will keep pulling away until they're too far apart to see each other. In the distant future, an observer in a lonely galaxy might look out and see nothing. Just darkness, with their galaxy all alone, floating in an invisible dough. Others think maybe, just maybe, gravity will slow it all down or dark energy will change in reverse. Nobody's certain. Even now, the nature of dark energy itself is a cosmic cliffhanger. You imagine for a moment being alive in that far-off lonely time. No other galaxies in sight. No evidence that the universe ever had a beginning. Just your one island of stars. And then you shake the thought away, glad that, at least for now, the cosmos is still full of company. In this very moment, surrounded by filaments and threads of light, you begin to appreciate the quietness of it all. Despite the fact that the universe is expanding and accelerating, out here there's no sense of hurry. The galaxies do not roar past you. They just glide apart slowly, gracefully, like dancers who have all agreed to drift to their own corners of the stage. You tilt your head and close your eyes for a moment. You listen. You imagine you can hear the faint stretching of space-time itself, the sigh of cosmic yeast at work. Of course, space doesn't make a sound, not in the vacuum. But in your mind you give it one anyway. A long, slow exhale like the universe breathing out. And as you open your eyes again, you realize you are still floating within this endless, rising loaf of stars. The horizon keeps slipping further away. And in the middle of it, you, tiny and calm, are caught in the gentle current of expansion with no walls, no limits, just a slow, quiet stretching of everything that is. You've been floating long enough now that you start to get an itch for a map. Not the kind you keep folded in a glove compartment with highways and rest stops, but a cosmic map. You know, the sort that could tell you, if you just go left for 3 billion light years, you'll find the cafe that serves stardust lattes. Except of course you don't have a map. And you quickly realize something both inconvenient and thrilling. Even if you had one, it wouldn't work the way you think. Because out here, the universe doesn't use straight, polite streets. Space and time themselves bend. They loop. They stretch and squeeze. They play tricks. And if you want to figure out where you are, the first thing you have to do is accept that the universe has a sense of humor. You start by imagining. Suppose you could pin stars like thumbtacks on a corkboard, nice and neat, and draw lines between them. In your head it seems easy. But the moment you try to line them up, your mental corkboard ripples like a sheet of water. Every bright point in the distance is moving, not just drifting but being carried along by the expansion of space itself. That spiral galaxy you just left behind? It's already further away than when you looked at it a second ago. That cluster ahead? It looks close, but by the time you reach it, the address has already changed. It's like trying to map a city where all the streets are made of jelly and keep shifting under your feet. You pause mid-drift, looking around. If you can't draw a neat, grid-like map, what kind of map does the universe give you? Well, you remember something scientists use? Coordinates that aren't just space but space-time. The universe doesn't think in terms of here and there, but here at this moment, and there a billion years ago. Because the farther away something is, the longer its light has been traveling to reach you. When you look at a galaxy 2 billion light years away, you're literally seeing a younger version of that galaxy. You're not looking at where it is now, but where it was when dinosaurs on Earth hadn't even shown up yet. It's a cosmic version of looking through an old photo album. You can't help but grin a little. Suddenly you feel like you're not just traveling through space, you're traveling through history. So you open your invisible map, the one that isn't printed on paper but in your mind. The first thing that shows up isn't a flat sheet. It's a web. Long threads of light stretch in every direction, knotted together like a gigantic spider web. This is what astronomers call the large-scale structure of the universe. Filaments of galaxies form the threads, and the spaces between them are vast, empty voids. You imagine yourself as a tiny glowing insect crawling on this web, feeling for vibrations. Where there are threads, there are stars. Where there are knots, there are galaxy clusters. And in between, great yawning abysses of nothingness. If you could see the map all at once, it would look eerily like the neurons in a brain. You wonder for just a second if the universe is thinking right now, and if your small drifting self is just a single firing signal somewhere in that grand thought. As you try to get your bearings, you think of another twist. This map isn't just three-dimensional. It includes time as a whole extra dimension, curled up like a hidden stairway. In this four-dimensional view, distance isn't just how far something is right now, but how far its light has had to travel. The farther out you look, the further back in time you're peeking. And so, when you stare deep enough, you find yourself looking at the cosmic microwave background. That faint glow of radiation left over from when the universe was only 380,000 years old. It's like hitting the wall of baby pictures in a family album. You've gone so far back that there's nothing before that to see, because before then the universe was too hot, too thick, and light couldn't travel freely. You stand there, well, float there, and think, if you could draw this map in layers, the very center would be now, and each shell outward would be an earlier time, almost like a tree trunk with rings. Except this tree trunk is 93 billion light years wide. That's one heck of a tree. And here's where the map gets trickier. Gravity bends it. You look at a distant quasar, a bright hyperactive galactic nucleus. Its light on the way to you has been bent by the mass of another galaxy. So what you see isn't a straight line at all. It's been curved. This is called gravitational lensing, and it means that if you try to draw a straight path from one star to another, it won't actually be straight. Your cosmic GPS is frankly hopeless. At this point, you realize something. No map of the universe can ever be permanent. It would be out of date the moment it was drawn. Everything is in motion. Galaxies shift. Even the very metric of space stretches. In a way, the only map that makes sense is one you keep redrawing every second. You can't arrive anywhere because the destination is always drifting too. You try to take stock of your own position. Are you closer to the center? But then you remember an important fact. The universe doesn't have a center. Or rather, every single point acts as if it's the center. From wherever you stand, you see everything else moving away. It's like rising dough. You don't need a special middle for all the raisins to drift apart. Every raisin sees all the others receding. That means your map isn't built around a single starting point. It's built around your own perspective. And someone somewhere else is making their own invisible map that looks completely different but is just as true. This makes you smile. The universe is fair that way. No one gets to be the center of everything. Every galaxy, every observer, gets its own expanding sphere of what it can see. Drifting deeper into this thought, you try to sketch your mental map again. But this time you let it move. You let the filaments wriggle. You let time flow backward and forward as if it's a ribbon being pulled in the breeze. You notice something strange as you do this. When you play with the coordinates, the very concept of straight paths dissolves. You can, in principle, draw a path that curves back to where it started without ever hitting an edge. A closed loop like walking around Earth without ever finding a wall. And that's when another scientific debate comes to mind. Is the universe flat or curved? Current data from cosmic background radiation suggests it's very close to flat, meaning parallel lines stay parallel forever. But it could still have a tiny curvature, one that only reveals itself over unthinkable distances. And if it does, you could leave your current spot and, after a very, very long time, come back to where you started, without ever seeing a boundary. That idea makes you dizzy in the best possible way. Out of the corner of your eye, a cluster of stars flashes, and you notice something odd. There are faint echoes of light appearing on both sides of it, like a mirror trick. That's the gravitational lens again, showing you the same galaxy in more than one place at once. Even the map itself gets playful, like a child sticking duplicate stickers in a scrapbook. And you realize the universe isn't just a physical landscape. It's a kind of mirage where paths, light, and time itself warp and overlap. At this point, you can't help but chuckle softly. You wanted a neat, folded map to help you find the edge of the universe. Instead, you've been handed a giant, shape-shifting labyrinth that doesn't even agree on what straight means. You hold the invisible map in your hands, if you can call them hands out here, and let it dissolve into glowing lines, each one representing a path not yet traveled, a road that may or may not stay where you put it. And while you stare at that dissolving map, you notice something, a glimmer, a path that seems to lead not to an edge, but to a horizon, like a faint, curved line where the visible ends and the unknowable begins. It calls to you quietly, like a faint whistle through a fog. So you fold your invisible map back into your mind, take a slow, steady breath, and start drifting that way. You keep gliding toward that faint curved line your invisible map whispered about. At first, it seems like just another trick of the light, a ripple in your vision, or maybe your imagination playing games with you. But slowly the background begins to change. The galaxies, once scattered thickly like spilled glitter, grow sparse. The web of filaments fades. The space around you starts to feel like the calm open sea, the kind where the horizon blurs and you can't tell where the sky ends and the water begins. And that's when you realize you're getting close to what astronomers call the cosmic horizon. This is the furthest limit of the observable universe. Not a wall, not a solid edge, but a boundary made of time itself. Because beyond this faint, hazy line lies a region so far away that light from there hasn't had enough time to reach you. It's not that nothing exists beyond this line, it's that no postcard from there has arrived yet. You slow down almost unconsciously. You feel like a ship sailing through a foggy sea, the mast creaking even though there is no mast. And ahead the mist grows thicker. It glows faintly as if made from the oldest embers of the universe. You try to look back over your shoulder. The universe behind you looks busy. Galaxies collide, stars are born, planets spin in orbits. But ahead the traffic thins out. There are fewer stars. And the ones you see appear red and stretched, tired from their long journey. You think back to that raisin bread metaphor. Those galaxies are like raisins that have been carried away so far by the dough of expanding space that their light can barely crawl to you. Some of them are already disappearing, not because they wink out of existence, but because the dough between you grows faster than their light can cross it. As you drift forward, you feel a deep calm. You can almost taste how the speed of light isn't just fast, it's a time machine. You aren't looking at galaxies as they are, you're looking at them as they once were. Every step forward is like reading an older page of the universe's diary. Somewhere around 13 billion light-years back in time, the galaxies look like infants. Tiny, messy, clumpy. Their stars haven't settled into graceful spirals yet. You see enormous, pinkish clouds of hydrogen gas, glowing under the light of the first stars. These first-generation stars, the astronomers call them population 3 stars, were huge, blindingly bright, but short-lived. They burned through their fuel in just a few million years before exploding into supernovae, seeding the universe with the first heavy elements. Every atom of iron in your blood once came from those early deaths. A poetic sort of recycling, really. You keep moving and the light gets older, thinner. You pass a region where stars barely exist, just patches of faint gas. And suddenly, you break through into something astonishing. A wall of light, faint and all-encompassing. This is the cosmic microwave background, the afterglow of the Big Bang itself. You are now looking at the universe when it was only 380,000 years old, when it first cooled enough for light to travel freely. Everywhere you look, it's the same. A dim, almost uniform glow, speckled with tiny ripples. You feel like a fish inside an amber bubble. It's warm in a ghostly way, not to touch, but to think about. This light has been traveling for almost 14 billion years just to reach you. You reach out as if you could push your fingers through it. It isn't solid. It's not even close to a wall. It's a time horizon. This is as far back as your eyes, or any telescope, can see. And even as you stand in awe, you remember, there's more beyond it. A whole universe full of things that have been happening, but whose light hasn't yet arrived. If only you could wait forever. For a moment you close your eyes. You listen to the silence and you imagine the universe just after the Big Bang. Hot, dense, noisy, filled with plasma so thick that photons couldn't escape. It must have been like a boiling pot of soup, a bubbling, bright fog. Only when it cooled did light break free, and that's the frozen echo you see now, stretched into microwave wavelengths by 14 billion years of expansion. You open your eyes again and you think, this is not an edge like a fence. It's a limit of vision. Like a foggy day on Earth, where the ocean just blurs away into the mist. The sky and the sea don't actually stop. You just can't see past that blur. Looking deeper into that blur, you see tiny spots where the glow is slightly warmer or cooler. These tiny fluctuations were seeds. Later, gravity took those minuscule differences and pulled matter into clumps. Those clumps became galaxies. Those galaxies became stars. And one day, billions of years later, one of those stars happened to shine on a small rocky planet where someone now floats, asking silly but beautiful questions about edges. The calm here is unreal. If you squint, you can see the faintest outlines of the surface of last scattering. That moment when the fog lifted. When light finally got to roam free. For some reason, the name makes you smile. The surface of last scattering sounds like something you'd find at the edge of a bakery counter, where someone spilled sugar one final time. Except this sugar is the entire cosmos. You drift along that surface, tracing your hand through the faint, cold light. Occasionally you spot something strange. Light bent into rings and arcs. The fingerprints of gravitational lensing even here, showing that mass, even invisible mass, is still shaping the final canvas you see. The map you made earlier folds itself in your mind again. You understand now that this horizon is the ultimate page of that map, the last picture currently available. But the human mind being what it is, you can't help but ask, What lies beyond? Are there other galaxies so far that their light hasn't yet begun the journey? Almost certainly. Whole structures, maybe even unimaginably larger patterns, could be waiting out there. Some scientists suggest that the unobservable universe could be much larger than what you see, maybe even infinite. Others even speculate there could be pocket universes, regions completely disconnected from ours, each with its own laws of physics. And here you are, a tiny voyager staring at the fog, trying to squint through it like a child pressing their face to frosted glass. You lean forward. The fog doesn't part. You can't cheat physics by leaning, but you can feel, for the briefest moment, that dizzying vastness, the kind that makes your thoughts slow down. You take a deep, slow breath, and as you exhale, you watch the fog gently ripple, as if acknowledging your presence. You pause and float in silence, trying to wrap your head around one simple fact. Light travels at a speed of 300,000 kilometers per second. That's so fast that it can circle the Earth 7.5 times in a single second. And yet, it has taken nearly 14 billion years for this particular light to reach you. The sheer scale of it humbles you. For a moment, you close your eyes again. You imagine yourself not as a person but as a grain of sand on an infinite beach, with waves of light breaking over you. Each wave is older than every civilization that has ever lived. A soft giggle escapes you, because of all the places to end up, you've drifted to the edge of the knowable. And still there are no walls. Just more questions. You let yourself drift, as if lying on the surface of a calm cosmic sea. The fog ahead stays still, but in your mind it whispers, there is more. For a long while you don't move. You simply float. Time becomes meaningless. You could be here for seconds or centuries. Eventually you realize, the horizon isn't a place you can pass. It's a place to pause. You carry that pause with you, like a small, glowing keepsake, and turn around slowly, ready to carry the question back into the busier parts of the universe. And just as you start to move, you glance one last time over your shoulder at the misty boundary. It looks, you realize, not like an end, but like the faintest beginning of everything. You turn back toward the fog even though you know you're not supposed to. You're supposed to accept it, float peacefully, let the horizon be the horizon. But curiosity has a way of tugging at you like a mischievous comet tail, and you, a tiny voyager with a stubborn streak, decide to do what no sensible scientist would recommend. Try to peek beyond it. At first you drift slowly, as if sneaking up on the mist might help. The glow ahead swells, the faint ripples of the cosmic microwave background getting closer, their patterns sharpening into a mosaic of warm and cool patches. It's like you found yourself swimming toward a frosted glass window that hides a glowing room behind it. And, of course, you want to press your nose right up against it. Just a little closer. You murmur to yourself, though there's no sound out here. You know this isn't an actual wall. It's a limit of time. Every step forward isn't taking you to a place so much as to an earlier and earlier moment in the universe's life. Right now, at the horizon, you're at 380,000 years after the Big Bang. And you think, what about 379,999? Or 1 second after the Big Bang? Or even before that? That's where your curiosity starts to burn. You want to cheat the clock. And so you push forward gently, as if you can slip past the curtain. At first, the glow doesn't resist. It washes around you like warm fog, and you float right into it. The moment you cross that line, everything changes. Inside the fog you see nothing. No galaxies. No clusters. Just an endless soup of particles, protons, electrons, photons, all tangled together in a tight, hot swarm. Light scatters in every direction, bouncing from particle to particle, like trying to see through a snowstorm of glowing marbles. It's chaotic, blinding. For the first time on this journey, you actually feel disoriented. You've entered what cosmologists call the opaque early universe. This is the part that telescopes can't see because light couldn't travel freely here. And yet there's a strange beauty in it. It's like drifting into a cosmic lava lamp. Bubbles of plasma roil and collide, forming patterns that swirl and vanish. If galaxies are the neat handwriting of the universe, this place is the scribble stage, wild, unrefined, full of raw energy. You stop for a moment and let the thoughts settle. Every single thing you've ever known, every tree, every planet, every drop of water, was once part of this glowing hot soup. The atoms in your body were all here, jostling, bumping into each other long before stars existed. You were a participant in this chaos without even knowing it. It's a strange sensation, almost like déjà vu. You feel tiny and yet connected. Deeper in you go and time starts to warp. You're no longer seeing space expanding the way you did before. Here, everything is happening so fast that it feels like time itself is running, stumbling, falling forward. A second passes, then a fraction of a second, then a billionth of a second. The fog thickens. The particles are now closer than molecules in a liquid, buzzing at near light speed. Somewhere in this blur, the temperature spikes unimaginably high, millions, then billions of degrees. Protons and neutrons smash together, creating the very first atomic nuclei. Hydrogen, a little helium, a tiny sprinkle of lithium. That's it. Those are the only elements the universe knows how to make in this phase. Everything else, carbon, oxygen, gold, will have to wait billions of years until stars can forge them. You pause in awe. This is primordial nucleosynthesis. It's like watching a blacksmith's workshop, except the forge is the size of the entire universe. And then you go even further, beyond the fog of particles, closer and closer to the first fraction of a second. Here your map, if you had one, completely dissolves. Space and time are stretching so violently that even directions lose meaning. Up, down, left, right, gone. Everything is a rolling, turbulent storm of physics itself. This is the era cosmologists call inflation. A moment so brief, so extreme, that the entire observable universe once fit into a space smaller than a proton. And then, in less than a blink, it ballooned outward faster than the speed of light. You try to picture it, but your mind refuses. You end up imagining a balloon the size of a marble suddenly becoming the size of a galaxy. And even that feels like a timid metaphor. And here's the wildest part. You realize you are still inside the same balloon. The expansion never stopped, it just slowed down. That balloon became the universe you've been floating through this whole time. The turbulence here is so intense that you begin to feel like a leaf in a hurricane. Waves of quantum fluctuations ripple around you, microscopic variations in energy that, over time, will seed everything that comes later. It's oddly poetic to think that tiny ripples in this baby universe will one day decide where galaxies form, where stars are born, and where a small blue planet will orbit a star. You take a breath. Well, if breathing even makes sense here. And you try to peek even further back. And then, something strange happens. Your sense of before starts to crumble. There comes a moment, a boundary called the Planck time, just 10 carat minus 43 seconds after the Big Bang, where our understanding of physics simply stops. Everything before this moment, we have no equations for it. We don't know if before even existed. Was there a singularity? Was there a bounce from a previous universe? Was there an endless inflation field bubbling with baby universes? No one knows. And here, at this frontier, even your imagination finds itself adrift. You realize you've crossed into pure speculation. Every step forward from here isn't a path, it's a question mark. You float in that unanswerable place. You can almost hear the voices of scientists debating. Maybe the universe began from a single point. Maybe there was a multiverse and we're just one bubble in a foam of infinite bubbles. And maybe time itself didn't exist before this moment. And you just listen. Because honestly, it's nice to let the questions be questions. The longer you sit here, the more you begin to feel something unexpected. For all the chaos and unknowability, there's a serenity in realizing that not everything has to be solved right now. Some mysteries just want to exist, like unopened letters waiting for a future reader. As you let your curiosity quiet down, you begin to drift backward again. Through the plank wall, through inflation, through the soup of particles, through the thick fog of light-scattering plasma, until you're back at the smooth glow of the cosmic microwave background. And as you emerge from the haze, the galaxies slowly return. Threads of light and structure weave themselves back into the picture. The cosmic horizon is once again behind you, a glowing blur. You pause for one last look at where you've been. The fog doesn't scold you. If anything, it feels like it's smiling at you, as if to say, you came as close as anyone can come. And that's enough. Drifting away, you realize that trying to peek beyond the beyond hasn't given you an answer. Instead, it's given you a deeper question. Maybe there isn't an edge. Maybe there isn't a single beginning. Maybe the universe is more like a song that has always been playing, and you just joined in on the verse that happened to be here when you opened your eyes. You take another long, slow breath, and with that, you let go of the urge to push forward. Not because the mystery is solved, but because, somehow, it's more beautiful unsolved. At first, you think it's a silly idea. A balloon? Really? After galaxies and fog in the baby universe, a balloon feels almost like a party trick. But as you drift along in the darkness, a faint, round glow begins to form around you. It starts small, then grows as if some cosmic prankster has been inflating something just for you. And then, there it is. A balloon so big that you can't even see its whole shape. Its translucent skin glimmers like soap film, faint rainbow hues swirling in slow motion. It doesn't spin or wobble. It just hovers, impossibly calm. You reach out and touch it. The surface is soft, elastic. And suddenly, in a very quiet voice in your head, the balloon says, "All right, curious traveler. Time to learn a trick." The balloon trick is simple but mind-bending. Imagine the surface of this balloon is all of space itself. Every point on it, that's a galaxy. Every tiny speck of dust, another world. Now imagine the balloon is slowly being inflated. As it expands, every point moves away from every other point. There's no single center on the surface. The whole surface stretches evenly. And here's the key. If you're one of the galaxies stuck to the balloon, you see all the others moving away from you, even though you aren't moving across the surface at all. You take a careful step, well, a sort of gentle shuffle, on the balloon's skin. At first, you expect to fall off. After all, shouldn't gravity pull you towards some outside? But the balloon has its own rules. It doesn't need an outside. For you, the surface itself is everything. It feels two-dimensional. A curved sheet, smooth and vast. You can go left or right, forward or backward. But in or out? Those directions don't seem to exist from where you stand. It's weird. On the one hand, this is a 2D world. On the other, you know there must be something more because you're looking at it from the outside. This, the balloon whispers, is a hint of how our own 3D universe might be curved in 4 dimensions. You sit down on the smooth, shimmering surface and start drawing imaginary dots with your finger. You make one dot, you. Then another dot, another galaxy. And another and another. Then, in your head, you start inflating the balloon. All of a sudden, all your dots get farther apart. The whole surface stretches. None of the dots are moving on the surface. They're just being carried apart by the surface itself growing. You realize, with a kind of gentle awe, that this is what the expansion of the universe feels like from the inside. You stand again and begin to walk. The surface beneath your feet feels springy like a trampoline that never ends. No matter how far you go, you can't see an edge. It curves softly, smoothly, forever. It dawns on you. If you kept walking long enough in one direction, you'd eventually come back to where you started. Not because there's a wall, but because the surface loops back on itself. That means, in a very real way, there's no edge here. You lie down flat, spread-eagled on the balloon, and look up. You see galaxies drifting away on the surface. From your perspective, it feels like you're at the center of everything. But you know that every other dot on this balloon thinks the same thing. The balloon giggles softly, like a wise teacher who enjoys watching students finally get it. And then something fascinating happens. As you're lying there, you start to imagine what would happen if you could somehow jump off the surface into the air outside. But the balloon shakes its head. There is no outside for you, it says. The surface is all you know. That other direction doesn't exist for you. This hits you like a quiet thunderclap. From inside the universe, we can't step out to see it from above. We can only experience it from within. The balloon starts to play tricks now. It makes tiny ripples across its surface, like waves on a pond. These ripples are gravitational waves, faint stretches and squeezes of the very fabric of space. You watch them travel outward, and when they pass under your feet, you actually feel the ground momentarily stretch and shrink. For a second you laugh out loud. You never thought a balloon could be so lively. You keep wandering. At some point you notice something subtle. The more the balloon expands, the thinner the galaxies appear on the surface. There's more and more space between them. And yet, from where you stand, you can never see the balloon stop. It just keeps stretching like bread dough rising in an infinite oven. While you walk, you start thinking about flatness versus curvature. If the balloon were small, the surface would feel obviously curved. You could sense that walking straight would eventually loop you around. But the bigger it gets, the flatter it feels under your feet. This is why, even though the universe might be curved, on the scale of galaxies it feels flat. Scientists have measured this with exquisite precision using that faint cosmic microwave glow you passed earlier. And the results? The universe appears incredibly flat. But that doesn't mean it's infinite. It might just be so large that we can't notice the curvature. And now you can't resist a thought. What if the balloon isn't the final shape? What if the universe is like a balloon, but with extra dimensions we can't even perceive? Could our 3D universe be just a kind of surface of something larger? Could there be other balloons nearby touching ours invisible? Scientists have whispered these ideas before in something called brain cosmology. The thought that maybe we're living on a 3D surface inside a higher dimensional space. And just like a bug on this balloon, we'd have no way of seeing that higher dimension. You pause and glance into the distance. Is there another balloon out there? Could it bump into ours? And if it did, would that be the Big Bang? The idea sends a shiver down your spine, but in a good way. As you walk, you start to notice something quirky. There are faint, tiny marks on the balloon's surface, almost like fingerprints. Maybe they're your own footprints from earlier, maybe not. Each mark corresponds to a fluctuation in the early universe, a place where slightly more matter gathered, later growing into galaxies. Even on this huge balloon, the tiniest imperfections can decide where stars will shine. You crouch down, pressing your ear to the balloon, and you hear a faint hum. It's not air. It's the hum of dark energy, the mysterious force that's making this balloon expand faster and faster. At first, billions of years ago, the expansion slowed down because gravity was pulling everything together. But after a while, this mysterious dark energy started to dominate, and the balloon began to accelerate again. It's still accelerating now, which means the farther you walk, the more quickly the surface is stretching away from under your feet. You take a deep breath and think about this for a while. The further out you look, the faster galaxies recede, until eventually they move so fast, thanks to the expansion, that their light will never reach us. In other words, there are regions of the balloon you'll never see no matter how hard you walk. And that's okay. You're starting to get used to the idea that not everything is meant to be reachable. You keep walking, and something funny happens. At some point, you realize you've looped back. The scenery looks familiar. The galaxies around you look like the ones you saw before. You've completed a giant cosmic lap. And you laugh, a deep belly laugh that echoes in this strange space, because the universe just pulled off the greatest joke. You kept looking for an edge and all you found was your own footprints. After a long while, you lie down on the balloon again, arms and legs spread. The elastic surface cradles you, rocking gently as if it were alive. You can almost feel the slow breath of the universe underneath you. The balloon whispers, "You see? Expansion doesn't mean there's an outside. It just means there's more room being created between the dots." You nod. It finally clicks. The balloon wasn't here to confuse you. It was here to teach you to imagine a space without an edge. And as you float there, on that massive, impossible surface, you realize that every galaxy, every cluster, every star you've ever passed is just a dot on this great skin of spacetime. And that skin is stretching quietly, endlessly. You sit up, take one last look around, and smile. The balloon fades slowly like a dream, leaving you once again drifting in open space. But something has changed. Now, whenever you look out, you can almost feel the curve of everything, even when it looks flat. You drift slowly, still thinking about that balloon, and a new itch starts to form in your mind. An itch that says, okay, I understand the balloon thing. I understand expansion. But if there's no edge, then where does the universe stop? The idea of no edge keeps slipping through your fingers like sand. So, naturally, you do the most human thing possible. You decide to go looking for an edge anyway. You start by imagining what an edge would look like. Would it be like the edge of a table, a clean drop-off into nothing? Would there be a sign saying, "End of universe, turn back now"? Or maybe a shimmering wall like the fog of the cosmic horizon, except this one would be solid, with a cosmic bouncer guarding the door? You picture yourself pressing your nose against it like a kid at a candy store. It's a funny thought. It also makes you realize how much of your everyday life is built around edges. Rooms, roads, countries, even the phone screen you're staring at, they all stop somewhere. And yet here in space, the rules seem to have taken a coffee break. So you aim yourself outward again toward what you imagine might be a cosmic edge. The stars behind you shrink. The galaxies grow faint like dust motes. And soon there's nothing ahead but a stretch of velvet black. You reach out your hand just in case. At first it feels like nothing is there. The void gives no resistance. You can move as far as you like and there's never a hint of a wall. And then, suddenly, your fingers brush something. But it's not solid. It's a change, like brushing through a breeze that isn't supposed to exist in space. You stop, heart thumping, if a floating cosmic traveler even has a heart here. What you feel is not a wall. It's more like a gradient. Space itself seems to thin out. You push forward and the sensation deepens. It feels as though you've just stepped into a place where the rules start to wobble. It takes you a while to realize what's happening. You aren't touching a thing. You're touching geometry. Remember that balloon surface you walked on? From a distance, you couldn't see the edge because there wasn't one. The surface just curved on itself. What you're feeling now is that same idea, but in 3 dimensions. The universe doesn't end. It simply curves. The more you move, the stranger it feels. If you try to go straight, you can sense a bend in your path as if the space beneath your feet is quietly guiding you. It's not like gravity pulling you. It's more like the entire fabric of the cosmos is wrapped in on itself. You test this by throwing an imaginary ball as hard as you can. You watch it disappear into the dark. And then, to your surprise, it comes back from the other direction like a cosmic boomerang. There it is, proof that the universe doesn't have an edge so much as a loop. This is where things get fun because you start to picture the universe as a giant game board with strange rules. If you keep going straight long enough, you might eventually come back to where you started. And you'd never find a cliff, never a sign that says exit. The universe might be finite but unbounded. Like the surface of Earth. You can walk around it forever without falling off an edge. You pause for a moment, staring at your hands. Your head spins a little at the thought. Edges that aren't edges. Boundaries that aren't boundaries. It's so contrary to everything you've been taught that you start laughing quietly, alone in the dark. Then a thought pops up. But wait, what if the universe really is infinite? What happens then? You stand perfectly still, as if that would help you imagine infinity. A universe that stretches forever in every direction. No curves, no loops, just more and more and more. You try to picture walking forever and never coming back around. That means no edge, not because it curves, but because there's literally no end. The more you think about it, the more you realize. Whether the universe is finite or infinite, there's still no edge to crash into. You can't resist trying again. You stretch out your hand hoping for something, anything, solid. But all you feel is the faint texture of space itself, and it's smooth all the way. It makes you wonder, why do we expect an edge in the first place? Maybe it's just because we grew up in small worlds, planets, buildings, rooms, where every journey eventually hits a wall. But here, space doesn't seem to share that habit. Of course, scientists aren't entirely sure of the exact shape. They've made careful measurements, studying the cosmic microwave background, and from what they can tell, the universe appears flat, with only the tiniest margin for curvature. If it's perfectly flat, then it could be infinite. If it's curved just slightly, it could loop back on itself. No one knows for sure. The data leans one way, but the truth? The truth might still be out there, laughing quietly like the balloon did. As you float further into the nothingness, you start noticing small peculiarities. Light bends in ways you don't expect. If you toss a beam of light forward, you notice it arcs ever so slightly. It's as if the light itself knows about the hidden structure, whispering, "There's more going on here than you think." The further you go, the more you start thinking about dimensions. You're used to 3, up, down, left, right, forward, back. But here you begin to suspect there might be others. Perhaps the edge isn't in front of you at all. Perhaps it's sideways in a direction your body can't point. Like a drawing of a circle on a piece of paper. A stick figure on that paper could walk forever and never know there's a third dimension above it. To the stick figure, there's no edge. Just a world that loops back on itself. And maybe we are the stick figures, living on the cosmic sheet, unable to see the whole page. You close your eyes for a moment and imagine it. Our 3D world might be curved in a dimension we can't see. To us, it feels endless. But from a higher point of view, it could be a beautiful, finite shape. Something simple and elegant. Maybe like a sphere or a donut or something even stranger. Some scientists have wild theories. One of them is that the universe could be a 3 torus. Picture a video game where, if you leave the screen on the right, you come back from the left. In such a world, you'd never find an edge, just a loop in every direction. Another idea. The universe could be like the surface of a saddle, infinite and yet curving in a way that stretches out forever. And yet another. Could be shaped like a giant pretzel. Which honestly would be a delicious twist. You think about all this as you float, and you can't help but grin. It's funny to imagine that the universe might be shaped like a pastry. But in the end, no matter what shape you pick, the conclusion is always the same. The edge that you're looking for isn't there. This realization doesn't feel disappointing though. In fact, it's a little freeing. Because without a wall, without a fence, you start to feel that everything is open. It's like walking on a foggy beach, where there's no horizon line to stop you. Just more steps, more gentle waves. You let yourself relax into that openness. For a while you simply drift, eyes half closed, letting the motion of the universe carry you. And then, with a sudden impulse, you imagine pulling out a piece of chalk and drawing a giant white line in the darkness. There, you say out loud, "Now there's an edge." You laugh at yourself. Even if you drew a million lines, space would just absorb them, because edges here are only in your imagination. You start to wonder about something else. If there's no edge, what does that say about you? About beginnings and endings? Maybe life, like space, has fewer hard edges than we think. Maybe the boundaries we see are just convenient ways to organize things. And maybe, deep down, everything just flows. The thought makes you feel lighter. Almost like a drop of water realizing it's part of the ocean. Eventually, you decide to stop reaching for a wall. You pull your hand back, fold it on your lap, and just float. The universe doesn't need to end for it to feel complete. You glance around. Stars, galaxies, faint threads of light. None of them look like they're in a hurry. And for the first time since you started looking, you aren't either. Somewhere in the distance, maybe light years away, you swear you hear a whisper. There is no edge. There never was. There is only the journey. You close your eyes and let that whisper settle in your chest like a warm glow. For now, you don't need a wall to lean on. The universe itself is enough. You never thought space could feel like a playground. But here you are, staring at something so invisible and so subtle. And suddenly your brain decides, this looks like a slide. And honestly, it kind of does. You drift closer. At first, space looks as smooth as glass. Galaxies are sprinkled like powdered sugar, floating, serene. But the more you watch, the more you notice that light itself doesn't travel straight. It bends, not sharply like a mirror, more like a ribbon caught on the wind. You start to follow one of these light paths with your eyes, and realize it curves down, dips, then arcs back up. You think, oh, space isn't flat at all. It's bending. And that's when the idea hits you. If space can bend, can you slide down it? Before you can second guess, you tilt your body forward. You let gravity, or rather the curvature itself, pull you in. It's not like a roller coaster. It's quieter. You feel yourself glide, smooth and slow, like a drop of rain rolling down a silk scarf. The slide you're riding on isn't made of anything physical. It's space-time itself. Every planet, every star, every galaxy, you included, is resting on this soft, invisible fabric. And whenever something heavy, like a star or a black hole, sits on that fabric, it presses down, creating a dip, just like how a bowling ball makes a dent in a trampoline. You glance around and see those dips everywhere. Big ones, small ones, some barely there. Each one sculpted by mass. Now you understand why your little glide feels so natural. Gravity isn't pulling you. Space is bending and you're just following the bend. This was one of Einstein's great insights back in 1915. Before him, people thought of gravity as an invisible force pulling objects toward each other. But Einstein looked at the same problem and said, what if there's no pulling? What if space just curves and everything moves along the curves? And he was right. Light, planets, even time, all of it bends because the fabric beneath them is bent. As you slide, you begin to notice something else strange. The closer you get to a dip, the more stretched time feels. Seconds start to lengthen like taffy being pulled apart. It's gentle, but you can feel it. This is gravitational time dilation. Down in a deep curve, clocks tick slower. So, for someone watching you from a flatter spot, you're moving in slow motion. Which makes you think, maybe that's why black holes are such time tricksters. Their dips are so deep that time itself gets trapped. You glance off to your right and see something amazing. A galaxy millions of light years away. Looks smeared, almost like someone dragged their finger across wet paint. At first, you think your eyes are playing tricks. But then you realize, you're looking at gravitational lensing. The light from that distant galaxy has passed near a massive cluster of galaxies on its way to you. The cluster's gravity curved space-time, and the light bent around it like a car taking a curve on a racetrack. The result? The galaxy looks stretched and magnified, as if the universe built a natural telescope out of curved space. You slow your slide just to admire it. These cosmic lenses are like funhouse mirrors, except they're deadly accurate pieces of nature's own optics. Astronomers use them to peer even deeper into the cosmos, seeing galaxies so faint they'd otherwise be invisible. As you keep gliding, the curves under you start getting more dramatic. Little dips give way to bigger ones. You begin to feel like a kid again, sliding down hills, rushing up the other side, each dip like a new adventure. You can't help but grin. Who knew general relativity could feel so fun? In the distance you see a giant, terrifyingly deep well. At the bottom of that well, everything is pitch black. No light escapes. You don't need anyone to tell you. That's a black hole. The slide into it is steep, almost vertical. Even from here you can feel the way time slows, the way light bends until directions make no sense. You stop. Even you, bold as you are, know better than to take that particular slide. You like sliding, yes, but you're not ready for a one-way trip. Instead, you linger at the edge, watching light circle it like moths around a flame, trapped in orbits called the photon sphere. And while you watch, a wild thought creeps in. If a black hole curves space-time so much, what happens inside? Does the fabric tear? Does it connect to somewhere else? Or does everything simply get squashed into a single, tiny point? Scientists don't know. This is another one of those spots where the universe shrugs and says, "Good luck figuring it out." You back away slowly, and return to a gentler part of the cosmic slide. Here the curves are subtle again. You notice how stars orbit their galaxies, how galaxies themselves orbit in clusters, all because they're following the invisible bends beneath them. No one is pushing them. They're just tracing the shape of the space-time hills. After a while, you realize that the entire universe is a gigantic, interconnected set of curves. Mass bends space. Bent space tells mass where to move. It's a dance with no music, but every orbit, every spin, every tiny wobble is part of the same choreography. Suddenly, you notice something curious. In between these dips, there are vast regions where space-time looks almost perfectly flat. No big curves, no deep wells. It's like a quiet plateau. Here you float effortlessly. For a moment, you almost forget you're sliding at all. And then, just when you least expect it, you drift near another massive cluster, and the ground beneath you starts to bow again. Down you go, slow and smooth, like a marble finding a groove. You start to get addicted to this. You even experiment a little. You tilt your body in different directions, just to see how the curvature affects your path. Sometimes a small star will bend your trajectory slightly, a subtle nudge, barely noticeable. Other times, a massive galaxy cluster will sweep you away in a grand arc. While you're having all this fun, another idea dawns on you. If the universe is curved like this, is it possible for the entire cosmos to have an overall shape? Could the sum of all these little curves form one giant cosmic curve? Would that shape be flat like a sheet, curved like a sphere, or stretched like a saddle? Scientists have tried to measure this using the cosmic microwave background, and their best guess? On the largest scales, the universe appears extremely flat. But here's the twist. Even a flat universe still has these local warps. It's flat on average, but up close it's like a quilt full of tiny dips and folds. You realize how delicate this balance is. If the universe had been denser, it might have collapsed back in on itself. If it had been less dense, it might have expanded so fast that galaxies never formed. But here it is, just right. A universe with just enough wrinkles to make it interesting. And that's when you see something that makes you stop sliding entirely. Ahead, there's a place where two curves intersect. like two slides crossing paths. You realize it's a gravitational wave passing through. The wave ripples through space-time, stretching and squeezing everything, and for a brief moment, your entire path wobbles like a trampoline. You ride the ripple laughing, as it gently tosses you upward before fading away. It occurs to you that the universe is never still. Even the fabric itself moves. These waves, born from colliding black holes or merging neutron stars, travel endlessly across the cosmos, forever changing the very shape of the playground. Finally, you decide to rest. You find a small, shallow curve and lie down in it, as if it were a hammock. You close your eyes and let yourself rock gently, feeling the slow, imperceptible pull of space-time beneath you. Sliding through the universe has taught you something simple, but profound. Gravity isn't a chain. It's not a rope pulling you down. It's the shape of the stage you're standing on. And when the stage bends, you just move along with it. The idea is so soothing, so elegant, that you can't help but smile. Even here, where everything seems chaotic, there's a kind of order, a flow, a path that curves, just enough to keep you moving. You take one last, slow ride down a gentle slope, feeling the invisible fabric cradle you, before you lift your head and look ahead, ready to see what the next curve will reveal. You thought it was quiet out here, silent enough that you could hear the hum of your own thoughts. But now, something curious slips into your ears. A whisper. At first, you think it's a memory, or maybe just your imagination after all these endless slides and balloon strolls. But no, this sound is different. It's like a handful of voices far away, conspiring at the edge of audibility. You tilt your head. The voices are gentle, excited but cautious. The kind of tone people use when they talk about something that's almost too big to say out loud. And slowly you start to pick up words. Bubble, one voice says. Foam, says another. And then, what if this is just one? You lean closer, not physically, just with your attention. And the whisper grows clearer. These are the scientists, or at least their thoughts, echoing in the void. They're debating something that feels like a secret. That maybe, just maybe, our entire universe is only one bubble in an infinite cosmic bath. You blink, because that's a lot. One universe already feels big enough. Now they're telling you there could be others? Like a never-ending foam. Each bubble its own reality, each one floating next to others. Bumping, drifting, separating? You try to picture it. If you step back far enough, farther than the cosmic horizon, farther than even your bravest imagination, you see it. A vast, shimmering bath. And in it, bubbles. Billions, maybe trillions. Some are tiny, fizzing out before they even get started. Others are enormous, as if someone blew them gently with a giant straw. Each bubble is a universe. And somewhere in one of those bubbles, ours, you're floating, listening. It feels impossible, but at the same time, strangely natural. You've already seen how space curves, how it loops, how it expands. Is it really so crazy that there could be more than one? You reach out a hand, and for a moment you swear you can feel a faint membrane, thin and soapy like the skin of a bubble. It trembles, alive, and beyond it, the faintest hint of another bubble. So close that if you pushed hard enough, you might bump right into it, but you don't push. Instead, you listen, because the whispers are still talking. They tell you there are many versions of the multiverse. One version comes from the idea of eternal inflation, that the early universe expanded so fast that different regions inflated at different rates, each one forming its own bubble of reality. Our universe is just one patch that cooled off, while others kept expanding forever. Another whisper says, what if quantum physics is also branching universes? In this view, every possible outcome of every event actually happens, just in a different branch. So somewhere in another branch, You are wearing purple socks instead of the ones you have on now. In another, you decided to stop listening and went back home. In yet another, you slid straight into a black hole back in Section 8 and, well, let's just say that version of you is having a very different day. You pause for a second, trying to wrap your head around this. If every choice, every possibility splits into a new branch, then the multiverse isn't just about space. It's also about possibility. The foam is bigger than you thought. You can't help but laugh a little. The universe, already huge, just went and one-upped itself. It's like it heard you say, "Wow, that's a lot," and replied, "Hold my supernova." The whispers continue. They tell you some universes might have laws of physics completely unlike ours. Gravity might be stronger there. Light might bend in weird ways. Maybe stars never form. Or maybe there are stars but no atoms. Or maybe everything happens backwards. Time flowing like a movie, rewinding endlessly. And then a softer voice says, "Most bubbles are probably empty." That hits you. You picture a lonely bubble, floating in the dark. No galaxies, no planets, no one to ask if it ever existed. Just a silent bubble that no one ever notices. It's a strangely tender thought. You almost want to reach out and give that bubble a hug. As the whispers swirl, you notice something subtle. They're not all in agreement. Some voices are excited, others cautious, a few skeptical, and they admit it. They don't know if the multiverse is real. It's just an idea, a possibility. There's no telescope that can peek outside our own bubble. Not yet. Maybe not ever. You ask them silently, "Then why imagine it at all?" The answer floats back. Because the universe we see raises questions it can't answer alone. And sometimes, the only way to make sense of the shape of our bubble is to imagine the bath it might be in. You sit with that for a while. It makes sense. You realize science is, at its heart, a form of curiosity, a willingness to ask the question, even if the answer lies forever out of reach. You turn your gaze outward again. If the multiverse is real, what would another bubble look like? Would its sky be green? Would it have its own galaxies, its own version of gravity, its own rules for how reality works? Would there be another you out there? A bubble twin, living a slightly different story? That thought makes you smile. You imagine them, another you, curious, wandering, maybe also looking at the soap skin of their own bubble, and wondering if anyone is out there, listening. You reach your hand forward, and for a moment, you tap the invisible bubble wall, just to say hello. And for a fraction of a second, you could swear something taps back. It could be your imagination, or not. You'll never know. The whispers start to fade now, like a tide going out. You catch a few last murmurs. Cosmic inflation, many worlds, anthropic principle, still just a theory, and then they're gone. The silence returns, thicker now, but not empty. It's a silence full of possibilities. You sit quietly for a long time, thinking about what you've just heard. The idea that there might be more than one universe doesn't make this one feel smaller. Oddly, it makes it feel more precious. Your bubble, your laws of physics, your stars, your blue planet with its silly little creatures who look up at the sky. All of it is a unique pattern in the foam. Even if there are infinite bubbles, no two are the same. And you? You are a ripple on the surface of this one. That's kind of wonderful, don't you think? You close your eyes and float there, pretending you're a soap bubble too. Round, fragile, glistening. For just a moment, you feel the faint pressure of the bath around you, holding you up. And as you drift, you realize, maybe the whisper wasn't really coming from scientists. Maybe it was the multiverse itself, calling out softly to its little bubbles, reminding them they're not alone. The thought makes you exhale, slow and deep. Whatever lies beyond your bubble can wait. For now, You're here, listening. You didn't think the multiverse whispers could leave you feeling small and thoughtful, but they do. So for a while you just drift, like a bit of foam in a quiet bath, and then something strange catches your eye. Not something you see exactly. It's more like something you don't see, a kind of absence. It moves across your view like a shadow, but there's nothing there to cast it. You tilt your head, blink, no change. Then you realize what you're looking at is a shape made out of invisibility, a hidden structure, stretching so far that even your imagination takes a deep breath before trying to map it. And just like that, you remember a word: dark matter. You've heard of it before. That mysterious stuff that makes up more of the universe than all the stars and planets put together. Yet no one's ever seen it. It doesn't glow. It doesn't shine. It doesn't even play with light. It's basically the world's best hider. You think, fine. If I can't see it, maybe I'll wear it. So you imagine pulling it toward you. Threads of something unseen, like strands of night, begin weaving themselves into a cloak. You drape it over your shoulders. At first it feels like nothing, weightless, cool, as if you've wrapped yourself in an idea. But as soon as it settles, you notice the difference. The universe lights up. Not literally, of course, but suddenly you feel the skeleton of reality. You see how the stars cling to invisible scaffolding, like beads strung on threads of silk. Those threads? They're dark matter. You glance down, and there's a galaxy beneath your feet. It spins like a lazy pinwheel, arms curling outward. Without the cloak, it looks normal, beautiful but familiar. With the cloak on, you can see its secret. A huge, invisible halo of dark matter surrounds it. It's bigger than the galaxy itself. Without it, the galaxy wouldn't hold together. The stars would fly apart like sparks from a campfire. This halo doesn't shine. It doesn't glow. It just is. And it pulls everything else along with it. You take a slow step, and the galaxy beneath you ripples slightly. It feels like walking on stretched fabric again. Except this time the fabric is made of gravity you can't see. You understand now why scientists first suspected dark matter. They noticed galaxies spinning way too fast. If they only had the matter we could see, stars, planets, gas, they should have flown apart ages ago. But something invisible was holding them together. Something massive. That invisible glue is everywhere. In fact, dark matter makes up about 85% of all matter in the universe. Everything you can see, stars, planets, you, is just a thin layer of frosting. The real cake is invisible. The cloak lets you follow it. You trace the strands outward, away from the galaxy, into a giant cosmic web. It's breathtaking. It looks like a spider decided to spin a web across the whole universe. Clusters of galaxies gather at the intersections, huge knots of light. Between them stretch the filaments of dark matter, quietly pulling, quietly shaping. As you walk along these invisible threads, you notice little details. Tiny dwarf galaxies, clinging like ornaments to the strands. Streams of gas flowing along the filaments, feeding star formation like a cosmic irrigation system. The occasional gap, a place where matter is scarce, like a silent valley between mountains. Without dark matter, there would be no galaxies, no stars, no planets, no you. You can't help but laugh softly to yourself. All your life, you thought you were looking at everything when you looked at the night sky. But the truth is, you've only ever seen a faint tracer of the real thing. Dark matter is the stage holding the entire performance. And somehow we're just lucky enough to stand on it. You twirl a little, letting your cloak swirl around you like mist. And as you do, you notice something else. Dark matter isn't completely silent. It hums. A deep, low vibration. So soft that you feel it more than hear it. It's the sound of gravity talking to itself. But there's still a mystery here. You can see what dark matter does. You can see its effects, the way it sculpts the universe. But what is it? The whispers of the scientists come back, like an echo from Section 9. This time, though, they're puzzled. It could be weakly interacting massive particles, says one. Or axions, says another. Or primordial black holes, says a third. The truth? No one knows. We've never caught one. We've never held a single dark matter particle in our hands. It's like chasing a ghost that leaves footprints everywhere but never shows itself. You think about this while running your hands over your cloak. It's so strange how something you can't see can be so absolutely necessary. Some scientists have even wondered if maybe we've misunderstood gravity itself. Maybe there is no dark matter. Maybe our equations are just a little off. But so far, the evidence keeps pointing back to something unseen, something real, something that refuses to take off its invisibility cloak. You decide to take a small leap, just to see what happens. The cloak holds you steady, and you land softly on another filament, this one leading to a massive galaxy cluster. It's enormous. Dozens of galaxies swarm like bees, all trapped in the same invisible halo. The dark matter here is thick, like fog you can almost feel. The cloak buzzes with it, alive. You stop to admire a scene. Two galaxies on a slow-motion collision course. Without the cloak, it looks like a chaotic smash-up. But with the cloak, you can see the halos of dark matter overlapping long before the galaxies themselves meet. It's like watching two invisible dancers start their duet, long before their hands ever touch. You wonder how many such dances have shaped the universe. How many mergers? How many collisions? How many spirals and swirls? All guided by something no one can see. And then you notice something that makes you gasp. The cloak lets you see the past. Not literally, not like a time machine, but in the patterns of dark matter. You can trace the history of the universe. You see where filaments pulled gas together, where galaxies formed, where stars lit up for the first time. The cloak lets you read these patterns like ancient wrinkles on the universe's skin. You close your eyes for a moment, and it feels like holding a map that's alive. You can almost feel the weight of 13.8 billion years, all draped around your shoulders. But even as you marvel, you know there's one more secret here. Because as heavy as the cloak feels, you realize there's another, even bigger presence in the universe. Dark energy. It's the force that pushes galaxies apart, fighting against the pull of dark matter. And the balance between the two is what gives the cosmos its shape, its future, its slow and gentle breath. The cloak you're wearing, as powerful as it feels, only tells half the story. But for now, that half is enough. You take a slow breath. The stars flicker. The web of dark matter hums. You've learned that the universe is built not just on what you can see, but on what you can't. And somehow, that makes it feel deeper, more mysterious, more alive. Eventually, you decide to take the cloak off. You fold it carefully and place it on an invisible hook. The universe dims again. The web disappears. But the feeling doesn't leave you. You can't unsee it now. You know it's there, everywhere, quietly holding everything in place. You float away with a small smile, your shoulders still tingling from where the cloak rested. It's strange, isn't it? Sometimes, the most important things are the ones you can't see at all. You thought the cloak of dark matter was light as air. But now, as you float onward without it, you realize there's something else out here that feels even lighter. So light that you didn't notice it at first, until it begins to push. It's subtle, like a breeze that sneaks up behind you. Not a shove, not a gust, just a soft, steady pressure. You turn around, expecting to see something chasing you. A galaxy, a star, a piece of cosmic lint. But there's nothing. Only the vast quiet. And yet you can feel it. A wind, invisible and everywhere. At first you think maybe this is just your own momentum. After all, you've been drifting through space for what feels like forever. But then you notice something. Everything around you, the galaxies, the filaments of dark matter, even the faint glow of background light, is being pushed too. All of it is moving apart. Not falling back together like you might expect. Not slowing down. Faster. And faster still. The wind is dark energy. You've heard of it maybe? That mysterious presence that makes up about 70% of the universe. If dark matter holds things together, dark energy is doing the exact opposite. It's pulling everything apart. Or is it pushing? The scientists can't quite agree on which word is better. It doesn't behave like anything else. The story of how they discovered it is almost funny, in a quiet cosmic way. For decades, everyone assumed the expansion of the universe was slowing down. Gravity is attractive. It pulls. So after the Big Bang threw everything outward, gravity was supposed to work like a brake. Maybe the universe would slow forever. Or maybe it would even collapse back in on itself one day. But in 1998, astronomers measured the light of very distant supernovae, and the result was the exact opposite. Instead of slowing down, the expansion of the universe was speeding up. It was like tossing a ball into the air, and watching it soar faster and faster instead of falling back. Nobody saw it coming. Something out there was acting like an anti-gravity force, and they called it dark energy. They don't know what it is. Not yet. Maybe a property of space itself. Maybe something more exotic like a field we can't touch. Or maybe it's a clue that we don't fully understand gravity at all. Whatever it is, you can feel it now. The gentle wind of it pushes at you. And once you tune into it, you realize it's everywhere. No corner of space is free from its soft nudge. You hold still for a while, just to see what happens. The wind picks up. Galaxies around you drift apart like dandelion seeds. The spaces between them grow. Even the filaments of dark matter, those thick, invisible threads you just walked on, start to stretch. You take a deep breath, and the wind slips into your lungs like cold, clear air. You let it out slowly. This isn't like the slides of curved space. It's not like the warm hum of dark matter. This is different. This is motion that comes from nowhere. You wonder, where is it pushing everything to? If the universe keeps expanding faster and faster, what happens to all these galaxies in the far future? You picture it. Right now, you can see hundreds of billions of galaxies. But as time passes and the expansion speeds up, more and more of them will slip away from view. They'll move faster than light can reach you, disappearing over the cosmic horizon. Billions of years from now, if anyone looks up at the night sky, they'll only see the galaxies nearby. The rest of the universe will be gone, unreachable forever. It's a little sad, but also there's something calming about it. The universe quietly tidying itself up, pulling the curtains closed around each cluster of galaxies. A slow, gentle retreat. You drift toward a region where the wind feels even stronger. Not because dark energy is thicker here. It's actually perfectly uniform. But because the emptiness is bigger. There's less to hold you back. In this emptiness, the wind is like an open plain. You could almost stretch out your arms and pretend to fly. And so you do. You let the wind catch you. It carries you effortlessly, sliding you across the great cosmic desert. The stars and galaxies fade into pinpricks. The web of dark matter becomes a faint haze behind you. All you hear is the soundless push. As you ride it, you can't help thinking of a sailboat. What if the universe is one giant sea, and dark energy is the wind filling its sails? You wonder, is there a captain? Is there a destination? Or is this simply what space does when it has nothing better to do? Stretch. Eventually you come to rest at a quiet spot. The view here is extraordinary. Galaxies are scattered like confetti, but you can see how their paths are diverging. You can almost see time itself accelerating. You try an experiment. You pick two galaxies at random and imagine drawing a line between them. You wait. The line grows longer. Not because either galaxy is moving through space, but because space itself is expanding between them. That's the strange thing. Dark energy isn't really a wind that blows through space. It's more like the fabric of space itself is stretching. Like a loaf of bread rising in the oven, carrying the raisins, the galaxies, farther apart. Still calling it a wind feels right, because you can feel it, the way it nudges everything around you. The scientists, of course, are still arguing. Some think dark energy is constant, that it will always have the same strength forever. Others suspect it might change with time. Maybe it will grow stronger, tearing everything apart. Or maybe it will fade away, leaving a quiet, coasting universe. One particularly dramatic scenario is called the Big Rip. In that version of the story, dark energy grows so strong that it rips galaxies apart, then solar systems, then planets, and eventually even atoms. It's not a bedtime story you want to hear before sleep. You shake your head and decide that's enough thinking about that for now. Instead, you focus on what you know for certain. Right now, in this moment, dark energy is gentle, persistent, but not violent. It's a hand on your back, not a hurricane. As you continue drifting, you see a galaxy that looks like a little swirl of light. It's so far away that its glow is faint, its light billions of years old. The dark energy between you and it has stretched that light into a softer, redder color. This is called cosmological redshift. It's like the wind has pulled on each photon, stretching it into a longer and longer wave. You think about how every photon from that galaxy has been traveling for so long, only to get tugged and slowed by the expansion of the universe. Even light isn't immune to this gentle wind. For a moment, you close your eyes and just listen to it, not with your ears. There's no sound here, but with that part of you that notices motion, that feels change. And you realize that this quiet wind has been blowing since the beginning. It has no smell, no taste, no edge, no pause. It simply is. You open your eyes and ask yourself a quiet question. What will this wind leave behind? One possibility is a cold, lonely universe. Stars will burn out. Galaxies will drift apart until they can't see each other. And in the end, there will only be emptiness. Another possibility? Something unexpected. Something no one has imagined yet. Because that's the thing about the cosmos. Just when you think you understand it, surprises you. For now, you don't have to know the answer. You just let the wind carry you. Slow, but you can feel it. Your hair, if you had any in this imaginary journey, would be streaming straight back. You notice that your own thoughts start to spread out too. Like the galaxies, the worries you carried with you. Tiny clusters of anxiety, nagging comets of to-do lists, start to drift apart, farther and farther away, until they're so far that they can't be seen anymore. It's a good feeling. Like the universe is telling you, let it go. Everything expands. Even you. The wind is so steady now that it feels like time has slowed down. Even as the universe itself speeds up. You lie back. Let it push against you. And you don't fight it. This, you think, is the rhythm of a cosmos that never stands still. As you drift off, or maybe just into a gentler state of being, you realize something profound. You've always lived in the wind. You just never noticed it. And now that you do, feels like the most natural thing in the world. You have been riding on the winds of dark energy for so long, that when you finally slow down, feels like stepping off a boat after weeks at sea. There's a soft sway in your balance, as if the universe itself is still gently rocking you. You blink, and the scene in front of you shifts. Not just in space, but in time. It takes a moment to realize what you're looking at. The light around you is older. It has that amber antique quality, as if someone has put a sepia filter over the entire cosmos. And you know instantly what's happening. You've drifted into the realm of galactic archaeology. No, there's no shovel, no trowel, no dust brush. Your only tools are light and patience. Because in the universe, every bit of light is a time capsule. The farther away something is, the longer its light has been traveling to reach you. So when you look out into space, you're really looking back in time. You take a slow breath and squint toward a galaxy so faint it looks like a whisper. Its light has been traveling for 13 billion years, which means the galaxy you see isn't what it looks like now. It's what it looked like before Earth even existed. You're staring at a baby picture. The feeling is uncanny. It's like walking into an old, ancient library, where the shelves go on forever, and every book is a frozen moment. And you, the curious traveler, are just pulling books off the shelf one by one, peeking at chapters written billions of years ago. You take a closer look. This galaxy is small, clumpy, messy. Nothing like the grand spirals and elegant ellipses you've grown used to. That's because back then, galaxies were still forming. They were colliding constantly, like toddlers bumping into each other. You drift closer, and with every light year, you feel like you're brushing off layers of cosmic dust, revealing older and older scenes. You realize that galaxies themselves are fossils. Their stars hold the chemical fingerprints of everything that came before. The first stars, for example, were made of only hydrogen and helium, the simplest ingredients. Heavier elements like carbon, oxygen, and iron came later, forged inside stars and then scattered when those stars exploded. That means when you study the stars in a galaxy, you can read its history and its chemistry. The oldest stars are like tiny time travelers. They carry stories from an era so long ago that even the galaxies themselves were just an idea. Astronomers have a name for these stars: population 3 stars. None of them have been directly observed yet. They're too old, too faint, and likely long gone. But their ghosts linger in the elements all around you. You glide into the middle of a star cluster, and as you do, you let your fingertips trail through the light, pulling out pieces like a gentle archivist. Here is a star made mostly of hydrogen, untouched and pure. Here is one a little younger, containing traces of carbon. Here is another with heavier elements like iron and gold, born much later in a supernova's fiery heart. Each one is a chapter. You can almost hear the universe speaking. This one lived fast and died young. This one took its time, slow and steady. This one created the iron in your blood, and this one the gold in your rings. The more you study, the more you realize that galaxies are layered like an archaeological site. The stars in their outskirts? Old, dim, often left over from ancient collisions. The stars closer to the center? Younger, brighter, born from the gas that settled after those collisions. If you dig carefully, you can reconstruct the whole family tree of a galaxy. You pull back for a wider view. Now, instead of looking at just one galaxy, you look at thousands, and you see patterns. You see how, over billions of years, small galaxies merged to form larger ones. You see the cosmic cannibalism, how big galaxies gobbled up smaller neighbors, stealing their stars like trophies. The Milky Way itself has done this many times. There are streams of stars in our own sky, remnants of dwarf galaxies we absorbed long ago. You hover above it all, watching these mergers like an archaeologist watching a time-lapse of empires rising and falling. Dizzying, but also beautiful, because every single merger, every collision, adds new layers to the story. You drift toward an especially bright patch of sky. There you see something that makes you stop. A galaxy cluster. Hundreds of galaxies, all huddled together, all bound by the invisible hand of dark matter. You zoom in, and you can see how the galaxies are not random at all. They are like cities built on an ancient trade route, connected by invisible filaments. Even here, the history is written in their arrangement. You reach out, and gently, you pluck a single photon from the cluster. It's been traveling for billions of years. It has seen more history than any library could hold. You hold it up to your eye, and you almost swear you can hear its story. A story of gas clouds collapsing, stars igniting, planets forming, and sometimes, life daring to open its eyes. You let the photon go, and it continues on its journey, quiet as ever. The deeper you look, the older the light becomes. Eventually, you reach a point where there are no more galaxies, just a faint glow. The cosmic microwave background. This is the oldest light in the universe, emitted when the cosmos was only 380,000 years old. Before this, the universe was too hot and dense for light to escape. Looking at it is like looking at the baby picture of everything. The background isn't uniform. It has tiny ripples, tiny temperature differences. Those ripples are the seeds of everything that came later. Galaxies, stars, planets, you. It's hard not to feel emotional, because those faint spots of light, 13.8 billion years old, are your beginning too. You pause. You think about how archaeology on Earth involves digging into the dirt, but out here, you dig into time. Every photon is a shard. Every spectrum is a pottery fragment, and the scientists back home are piecing it all together. To understand how the universe became what it is, you smile. You've become part of the excavation, a visitor in the grandest museum there has ever been. The walls of this museum, the universe itself. You smile. You've become part of the excavation, a visitor in the grandest museum there has ever been. The walls of this museum, the universe itself. There's a soft voice in the back of your mind. It says, "Don't forget, everything you see out here is history. Even the stars above your head tonight on Earth. Those are ghosts, still shining from the past." And you realize that even though you are out here in the endless present, you're always looking backward. There is no way to see the universe as it is now. You can only ever see it as it was. That makes you wonder, what does the universe look like in this moment? Right now, everywhere? No one knows. No one ever will. We're all archaeologists, digging up the past and imagining the present. You take one last slow spin, looking at all the layers, all the timelines stacked on top of one another. It's overwhelming, it's humbling, and it's oddly comforting, because you realize that everything, every atom, every star, every galaxy, is a record, and that means that nothing is ever truly lost. You decide to leave this ancient archive for now. You tuck all the stories into a corner of your mind, careful not to let any of them scatter in the cosmic wind. And as you drift away, you glance back one last time. From a distance, it all looks like a glittering mosaic, each tile a fossil of light, a perfect, endless museum. And you, tiny but curious, have just walked its halls. You've been sifting through the layers of the universe like an archaeologist, peeling back the starry wallpaper of time, until finally there is no more wallpaper left to peel. And then you realize what you've been moving toward all along. Not a place, not even a moment, but the beginning. You slow down, very slowly, until you are almost still. The galaxies behind you fade into mist. The cosmic web becomes a faint suggestion, then disappears altogether. All that's left is a dark, humming quiet. And in that quiet, you realize something simple. You are approaching the moment when time itself woke up. You might expect this place to be loud. A big bang explosion, fireworks everywhere. But the truth? It's so still here you can hear your own thoughts. Like the universe is holding its breath. Because, in a way, There isn't a here yet. You try to imagine what before looks like, but your brain slips and stumbles on the word, because before time began, there was no before, no after, no in between. Just a silence so perfect it doesn't even know it's silent. And then, like a pair of sleepy eyes, time opens, not with a bang, more like the first slow blink after a long nap, a kind of cosmic, oh, I exist now. At first it's small, a single moment, then another, and another. You can almost see the seconds learning how to walk. The universe isn't a place yet. It's a rhythm, a pulse, the tiniest ripple spreading out in all directions. Space stretches, energy flares, and time keeps stepping forward, one hesitant foot after the other. You drift closer, though there is no closer here, just different flavors of early. The light here is so hot, so thick, that it's not even light as you know it. It's a blinding soup of particles, all bumping into each other so fast that nothing can hold still. Quarks, tiny bits that will one day form protons and neutrons, flash in and out of existence. Gluons, which sound like something a science fiction writer made up, are stitching them together. And everything is expanding at a speed so fast that if you tried to measure it, your ruler would stretch along with it. This stage has a name: inflation. It lasted only a fraction of a second, but during that blink, the universe grew from smaller than an atom to something you could actually see with your cosmic eyes. That seems ridiculous. Well, it is, and scientists still argue about how, and why, and what triggered it. But without it, you wouldn't be here. You float through this newborn chaos, and you start noticing patterns, tiny differences in density, minuscule wrinkles in the otherwise smooth fabric. These little ripples will one day become galaxies. Right now they're just faint hints, like pencil sketches on a blank canvas. A few minutes into this new timeline, not your minutes, but the universe's minutes, things begin to settle down, just a little. Particles start forming stable bonds, protons, neutrons, and for the first time, atomic nuclei appear: hydrogen, helium, and a sprinkle of lithium, the three oldest elements. That's all the universe knows how to make right now. The rest will come later inside stars. You smile, because you know this messy hot soup is the ancestor of everything: trees, oceans, music, ice cream. But you still can't see anything. Not yet. The light is trapped, constantly bumping into charged particles. It's like being stuck inside an endlessly glowing fog, with no way for the glow to escape. It will take 380,000 years for the universe to cool enough, for atoms to form, actual neutral atoms that let light finally travel freely. And when that happens, the fog will lift, and the light will spread everywhere. That light, billions of years later, will become the cosmic microwave background you just visited in section 12. Right now, though, you are floating in the moment before the fog clears. It feels oddly intimate, like sitting in a room before someone turns on the lights. You know it's coming, but you're savoring the quiet anticipation. You reach out a hand. Not that there's really anything to touch, but you feel the hum of time stretching around you. You think about the word bang in Big Bang. It sounds so explosive, so loud. But the truth, from the inside, feels like a bloom, not a bomb. A flower opening in slow motion. The petals are made of time and space, unfolding gently but relentlessly. As you float here, you realize how strange it is to be looking at the beginning, with a mind that came from the end of the story. You're like someone who walks into a theater, just as the curtain rises, but with the entire plot already spoiled. You wonder, was there anything before this? Did time have a rehearsal before the main performance? Or did it simply appear out of nowhere, with no explanation? No one knows. Maybe there was something called a quantum fluctuation, a weird burp in nothingness. Or maybe our universe is just one bubble in an eternal foam, each bubble inflating in its own time. Or maybe these are the kinds of questions that time itself won't let you answer. For now, you stop asking. Instead, you just watch. Because there's something extraordinary about seeing something come from nothing. The expansion keeps going. Seconds stretch into minutes. Minutes stretch into years. Stars haven't formed yet, but the stage is being set. The universe is still so hot that everything glows, but you can sense that the chaos is slowly calming. It's a baby, breathing its first breaths. You wonder what it would be like to whisper to it, to tell it what it will become. You'll grow stars, you might say. You'll have planets, and oceans, and creatures that wonder where they came from. You'll become galaxies so beautiful they'll take your own breath away. Would the young universe believe you? Or would it laugh? Or maybe it wouldn't care. Because right now, it's just focused on existing. And that's enough. As the fog of particles swirls around you, you can't tell where space ends and time begins. They are born together, like twins holding hands. You feel them stretching around you, wrapping you in a cradle of beginnings. At some point, you find yourself drifting into a strange calm. It's as if the expansion has slowed just enough to let you take it all in. The heat is still intense, but there's a rhythm to it now, a pattern, and you realize this is it, the very first heartbeat of everything. You close your eyes, and in that darkness, you feel the pull of countless futures, galaxies, stars, planets, life. All of it already written in these first trembling ripples. Time, once shy, is now wide awake. It looks at you with a kind of soft wonder, as if it's surprised that something as strange as you will eventually come out of it. And then you drift back, slowly, carefully, as if leaving a newborn alone in its crib. Because you know this moment is precious. You don't want to disturb it. You just wanted to see it with your own eyes. When you finally turn around, the galaxies start to appear again in the far distance. But the memory of what you just saw, the beginning, the first blink, stays with you. You carry it like a quiet flame, and you think to yourself, maybe that's all time ever wanted, to open its eyes, so one day, something could open theirs. You are still carrying that flicker of the first light, the memory of time's sleepy eyes opening, when you begin to notice something strange. It isn't loud, it isn't sudden, it's a whisper, soft, uncertain, and a little hesitant, and it's saying, could it all end? You pause mid-drift. It's almost funny because after watching the birth of time itself, you've started to believe that the universe might just keep going forever, like a never-ending story, always adding new chapters. But the more you listen to that whisper, the more you realize this is a question that scientists, philosophers, and dreamers have been asking for a very, very long time. You look around you. Everything is so vast, so spread out. It's hard to imagine it all coming to an abrupt halt. And yet, the possibilities are out there, like seeds blown by the same cosmic wind that pushed you through the void. The whisper grows a little louder now, and it begins to offer you possibilities, different endings, like someone showing you alternative finales to a film. The first ending? They call it the Big Crunch. In this version of the story, gravity eventually wins. For all these billions of years, it's been in a tug-of-war with expansion. Right now, expansion is ahead, thanks to dark energy pushing everything apart. But what if, one day, dark energy changes, weakens, stops? Then gravity, patient and relentless, could slowly begin pulling everything back together. You imagine it, galaxies slowing their race away from each other, turning back as if hearing an ancient drumbeat calling them home. Clusters collapse. filaments tighten, and over billions of years, all of space folds inward. The stars in those future skies would get closer and closer until the night looks like a cosmic bonfire. Heat would rise, galaxies would merge, black holes would devour everything, and in the final act, all matter, all light, all time itself would be crushed back into one point, like the beginning, but in reverse. A final exhale. And after that, does it start over? A new Big Bang? A cycle, endless and eternal? No one knows. The whisper doesn't answer. The second ending is colder. Much colder. This one is called the heat death, or sometimes the big freeze. In this version, dark energy never weakens. It keeps pushing everything apart, faster and faster. The galaxies drift so far apart that their light can no longer reach each other. Stars burn out one by one, leaving behind only faint embers, white dwarfs, neutron stars, and black holes. Eventually, even black holes will evaporate, a slow, patient process called Hawking radiation. And when the last one finally disappears, there will be nothing left but a thin, cold soup of particles, spread so thin that there's no structure left at all. No galaxies, no stars, no life. Darkness at absolute zero. It's not a dramatic ending. There's no explosion, no curtain falling, just a long, slow fade out, until there's nothing left to fade. You shiver, even though there's no temperature out here that can touch you. That future is so lonely that it almost feels personal. The third ending is the most dramatic. It has a name that sounds like something out of a horror movie, the Big Rip. In this scenario, dark energy doesn't just keep expanding, it gets stronger, much, much stronger. So strong that eventually, it overpowers every other force. First, it tears galaxies away from each other. Then it rips apart solar systems. Planets can no longer hold their orbits. Then, as the strength keeps growing, it breaks apart the planets themselves. It doesn't stop there. Atoms, once the solid little building blocks of everything, can't resist. Even the protons and neutrons get pulled apart until there's nothing left but a featureless, shredded space-time. You let out a long breath. Intense. You decide that if the universe has to end, you prefer the quiet endings over the dramatic one. You sit there for a while, letting these three possibilities swirl around you. The big crunch, the big freeze, the big rip. Three different fates, and no certainty. You ask the whisper, which one is true? And of course, the whisper answers honestly, we don't know. Scientists are still trying to measure the shape of the universe, the amount of dark energy, the exact rules of how it behaves. Right now, it looks like the universe will keep expanding forever, so the big freeze is our best guess. But even that is uncertain. The universe has surprised us before. There are even other, stranger ideas. Some think the universe might be a simulation, and one day someone might just switch it off. Others wonder if time itself might decay, like a candle burning down, until there's no more moment to move into. Some imagine the universe tunneling into a new state, like the floor beneath us giving way, in an event called vacuum decay. No warning, just a sudden rearrangement of everything. It's an unsettling thought, but also strangely freeing. You shake your head. All of these endings, and none of them are things you can control. That's the strange piece of it. The cosmos doesn't need your permission to end. So instead of worrying, you do what you've been doing all along. You look at the galaxies around you, spinning, burning, colliding, living their own luminous lives. You look at the empty spaces between them, vast as oceans, and you think, right now everything is still here. Maybe that's the secret. The universe could end tomorrow, or in a trillion years. But for this moment, right here, right now, it hasn't. The stars are still burning. The galaxies are still dancing. Time is still unfolding like a ribbon. You stretch out, and the whisper softens again, as if it's satisfied that you've heard it, but also that you understand. It says, "Don't worry so much about how it ends. Enjoy that you're part of it while it lasts." That feels like good advice, because if there's one thing you've learned in this journey, it's that the universe is not just big, it's generous. Generous enough to make space and time, and then stars and planets, and then creatures who ask questions about all of it. You decide that, for tonight, you'll stop thinking about endings. Instead, you'll just listen to the slow, endless hum of now. As you drift away from that whisper, you realize that no matter how the story finishes, you've already seen something incredible. That existence happened at all. And maybe, just maybe, that's the best ending there is. You've been traveling for what feels like forever. Through time, through the folds of space. Through ideas so big you had to hold your breath just to stand near them. You have touched the first shimmer of time itself. You've traced the invisible threads that hold galaxies apart. And you've heard the quiet speculation that maybe, someday, even all of this will end. And now, after so much outward wandering, you realize something has been quietly waiting for you all along. Not out there, but here. You have not yet looked back at yourself. It happens the way most important things happen. Unexpectedly, softly, as though the universe knew you needed a moment to notice. You pause. Not because there's an edge in front of you, but because something feels different. You turn your head, ready to see another wave of galaxies. And instead you catch sight of something impossibly small. At first, it's just a faint glimmer, barely more than a piece of dust floating in a sunbeam. A dot so small, you could cover it with the tip of your finger, and yet it pulls at you. It feels familiar in a way that nothing else in all these cosmic miles has. You drift toward it, and the details sharpen. Blue swirls, thin white streaks of cloud, brown and green patches that look like someone spilled watercolor on a marble. It is, of course, home. Your planet. Your improbable, fragile, dazzling planet. You slow down as you approach, as if afraid you might wake it. It spins gently in the dark, quiet and utterly unaware that you've just traveled across the whole cosmos to look at it. From this distance, you can see no borders, no flags, no words on maps, just one round shimmer. And it occurs to you that for all your time chasing the infinite, the only truly solid thing in the entire universe is the soft gravity of this little blue world pulling you home. You get closer still, close enough to see that the light on its oceans glints like spilled mercury, and the clouds move so slowly, they look like they're dreaming. You want to reach out and hold it in your hands. You want to tell it, "I've seen so much, and yet there's nothing like you." And here's the thing. It isn't the size of Earth that impresses you. It's the miracle of chance. Think about it. In a universe that could have been just endless gas and rocks, here is a place that somehow learned to grow trees and whales, and jazz music, and the very specific flavor of strawberries. All of that, on a tiny pebble. You shake your head, because when you've been staring at infinity for so long, it feels absurd that this little rock could carry something as complicated and extraordinary as life. For a moment you feel small, truly small, compared to the size of the cosmos. You are less than a single pixel in a photograph that is already impossible to print. But then, slowly, something inside you starts to turn. Small doesn't mean unimportant. Small doesn't mean invisible. In fact, small is sometimes the only way that infinity can notice itself. You float, and you start thinking of everything that has ever happened on that dot. Every great story, every heartbreak, Every moment someone laughed so hard they couldn't breathe. The first time a human learned to make fire. The first painting on a cave wall. The first hug between two people who thought they were lost forever. It all fits there, on that tiny dot. The whole tapestry of history. All the science, all the music, all the little jokes and all the big mistakes. Everything that makes life, life. And you, right now, are part of it. You're woven into it so deeply that even from the other side of the galaxy, it feels like you can still hear your own heartbeat coming from there. As you stare at your planet, another thought rises quietly. After all these chapters of your journey, looking for an edge, trying to imagine what comes next, diving into how things began, you have been carrying a quieter question all along. Where do I fit? And here's the answer. You fit right here. Exactly here. Because here is where the universe finally slows down enough to notice its own existence. Through you. Through all of us. You are literally made of stars. The iron in your blood. The calcium in your teeth. The carbon in your skin. All of it was forged in the violent hearts of long-dead stars. Billions of years ago, those stars exploded. And from that scattered dust came everything you now are. It's a very long chain of events, just to get to a being who can sit in bed and listen to a gentle voice talk about the edge of the universe. And yet here you are. You think about your daily life, the cups of tea, the unanswered emails, the sound of rain against a window. None of it seems big enough to matter in the scale of the cosmos. But when you remember that you are stardust that learned to love tea, suddenly those small moments feel like the universe enjoying its own creation. It's like the cosmos wrote a poem, and the last line was, "And then they made pancakes on a Sunday morning." From here, your troubles look different. Not gone, just smaller. You know that when you go back, your life will still be messy and human, but maybe you'll carry a little more space in your heart for the wonder of being here at all. You think again about the endings you learned in the last chapter. Big crunch, big freeze, big rip. You realize that none of them actually change what you feel in this moment. Because no matter how the story ends, right now the story is still being written. And for the short time that you get to be alive in it, you are part of the ink. The earth turns slowly below you. Night rolls across continents like a blanket. The cities light up, little constellations of their own. You can almost hear the sound of people settling in for the night. A kettle boiling, a door clicking shut, a lullaby in a language you've never heard. Every window glows like a soft, tiny star. And you realize something simple. In a universe that doesn't seem to have an edge, home isn't a place you can point to on a map. Home is wherever there are lights that wait for you. You start to drift back, but more slowly than ever before. You're in no hurry. The stars don't look so cold anymore. They look like family. The empty space doesn't feel empty. It feels like a big, sprawling neighborhood. You glance back one more time at infinity. No walls, no fences, just a horizon that keeps moving further the more you try to reach it. You finally understand that there is no center. There's no special place where everything begins or ends. But there is a center for you, a center you carry in your chest. It's a small, steady light. It's been with you the whole time. You drift closer to Earth, through the thin layers of atmosphere, past the whispering clouds. You almost feel the warm air again, and the smell of trees, and the sound of water moving over stones. And with that, you land back into yourself, not as a wanderer, not as someone searching for an edge, but as someone who finally knows. Infinity was never out there. It was always inside you. You take one last deep breath. You let it out slow and full. And in the silence, the stars seem to answer. Yes, this is where you belong. There's still a whole cosmos out there. You'll keep wondering about it, of course, but you know that For tonight, you have found your place, and it is not at the edge. It is right here, in the middle of everything. The stars are very still now. All of those grand spirals and glittering clusters you have been traveling through seem to pause for you, as though the universe itself wants to give you this last quiet moment before you drift away into sleep. You've been out there so long tonight, chasing edges, chasing horizons, and now you are here, back where the air is soft and slow, where your body remembers the shape of home. Breathe in, breathe out. Let that breath feel like a tide, not rushing, not urgent, just rising, falling, rising again. Every breath you take now feels like a tiny planet orbiting a sun, round and round, perfectly balanced, perfectly safe. Imagine for a moment that you are no longer heavy, that the weight of your day, the list, the noise, the things you said and didn't say, all of it has been placed gently on the floor beside you. What's left is only you, light as dust, floating. Picture the room around you. See how it fades. The ceiling becomes a soft sky. The walls melt away like mist. In their place there is a wide, calm night, stretched from one horizon to the other. Above you is a river of stars. They move very slowly, so slowly that you can imagine each one like a small lantern someone has hung there just for you. You lie there, and the longer you look, the more you realize the stars are watching you back. Not with judgment, not with expectation, just with that steady, patient light they've been carrying for billions of years. Feel how soft that makes your body. The weight in your shoulders begins to loosen. The muscles behind your eyes, all those little knots from thinking and thinking, untangle. Even your hands unclench, as though they too have been holding the universe too tightly, and can finally let it go. Take another slow breath, and with that breath, imagine that you are drifting, just like before, but now there is nowhere you need to go. You are no longer a traveler. You are a seed of light, floating on a current you don't need to steer. Somewhere far above, galaxies still spin, stars still ignite, planets still collide and form. The great orchestra of the cosmos keeps playing, but it's soft here, muted, as if someone has turned down the volume just for you. And now, listen carefully. You can almost hear it, a low, slow hum, the universe itself, singing you a lullaby. It sounds like wind across a desert, like waves sliding back from a shore, like a memory you can almost remember, but not quite. With every note of that hum, your body grows warmer, your breath grows slower. You are sinking, but not in a scary way. Sinking the way a pebble sinks into a very soft pillow, finding the exact place where it was always supposed to be. You feel yourself blur at the edges, not disappearing, just softening. It's as though all the hard lines of today, the sharp moments, the rushing thoughts, are dissolving. You are a watercolor painting now, and the colors are spreading outward into the night. As you drift there, you realize something. All this time, you've been looking for where the universe ends, but maybe it doesn't end at all. Maybe it just becomes this stillness, this peace, this quiet, where you finally get to rest. Think of all the places you've been tonight. The edge that wasn't an edge, the galaxies like lanterns, the winds of dark energy that pushed you faster and faster, the first blink of time itself. And now, look at where you are, back in the one place where you can finally close your eyes. This bed is not a spacecraft, but tonight it doesn't need to be. This room is not the size of a galaxy, but tonight it holds the whole sky. This breath you are taking right now is the same air that has been circling the earth for billions of years. Every single particle of it has been through mountains and oceans and trees and at least one star long before you were born. And now it is yours. Take another slow, deep one. Feel how it moves in and out, as if the universe is rocking you to sleep. You are safe here, completely safe. The stars will stay awake. They always do. Let your eyes grow heavier. Let the night draw closer. Imagine that your body is turning into a constellation. Every thought a tiny star, clicking into place as you stretch out along the sky. And slowly, those thoughts fade until only the stars are left. There's no hurry now, no deadlines, no tomorrow yet. There's just this, a vast and timeless sky, and you, falling gently into it, like a pebble into calm water. And as you finally drift off, know this, you are not small to the universe. You are not forgotten. You are one more point of light in a sky that has no end. And that is enough. Good night, traveler. Sleep well. When you dream, dream in galaxies.